Hello, I hope you're doing well today. We're going to start with an opener. I'd like to look at a function that you're familiar with. Let's let y equal the natural log of x. I want to graph the function and identify what's the domain and the range. You might want to hit pause and go ahead and jot this down and then continue. Alright, so first of all, we know what the natural log of x looks like. So put 1 there, and it's asymptotic with the y-axis. It's increasing everywhere. Okay, so now let's do our domain. Our domain is x has to be greater than 0, or if you write that with interval notation, with the IB interval notation, that would be 0, comma, infinity, brackets opening away from 0 and infinity because we're not including those. Now, what about the range? The range, what are all the possible y values? Well, that can be everything. So it's actually negative infinity to infinity. Obviously, we don't include the infinities. So there we go, that seemed easy enough. Okay, next question. I'd like you to graph y equals 1 over x and find the domain and range for that. I know you're wondering, where is this going? So let's go ahead and graph y equal 1 over x. Hopefully you didn't have to think too much about this. You should have seen this enough. This is one of those parent functions you should be familiar with. And not drawn super accurately, but they both go through the point -1, -1, and 1, 1 for each of these pieces. Right there and right there. Okay, so what's the domain? Well, you can see that it takes on all possible x values except 0. So all real numbers, x cannot equal 0. Or if you're using interval notation, I guess that would be negative infinity to 0. Union with 0 to positive infinity. And what about the range? The range is exactly the same thing. It takes on all y values except 0, so I'll just put some quotes here for that. So exactly the same as the domain. Okay, so now why am I asking you about these? Well, because what if we wanted to find the integral of 1 over x dx? And this is a subtle point, but it's important, and so a lot of times students tend to overlook this. So when I give you this problem, find the integral of 1 over x, looking at this integrand function, you realize that x can be anything except 0. Okay? So x can be anything except 0. Oops. Let's put that back there. And when you come up with your answer, you think, well, what function is the antiderivative of 1 over x? And you think, the natural log of x. And so you differentiate to make sure that you got the right answer. What's the derivative of natural log of x? It's 1 over x. Everything seems fine. But the problem is, if I just write this, and then plus any constant, the domain for this, we said, was x can be anything except 0. That means x can be a negative value. But what happens when we take a negative value and plug it into the natural log of x? That causes a problem, because the natural log only accepts positive values. So how do we deal with that? So actually, we're going to write the natural log of the absolute value of x. And there's your solution. So when you see the integral of 1 over x, don't forget that you have to put absolute values around your argument with the natural log because of that domain issue. All right. Let's look at another important example that a lot of times students forget or are not sure how to handle. So we're going to take a little detour. What are the double angle formulas for cosine of 2x, sine of 2x? Now that was a while back. You might have to go back and look those up. Those actually I think are in the formula packets as well. So it turns out, let's do the sine of 2x. That was 2 sine x cosine x. And if you remember, this is how I remember all the other ones. I remember the 6 sine of a plus or minus b, cosine a plus or minus b, tangent a plus or minus b, and all the other trig formulas can be derived from those. Alright, so I remember that the sine of a plus b is equal to sine a cosine b plus cosine a sine b. And if you remember that, that's how you can remember, well, we can combine those and we have 2 sine cosine, because the arguments are the same. Alright, but what about the cosine of 2x? Do you remember that one? So it turns out that there were actually 3 different formulas for this. So the first one, the main one, is cosine squared of x minus sine squared of x. Now with the Pythagorean identity that sine squared plus cosine squared equals 1, we could convert, and let's say we switched and changed the sine squared to be 1 minus cosine squared from the Pythagorean identity. So what would happen then when we simplify? We'd have cosine squared minus the quantity 1 minus cosine squared, and so that would give you 2 cosine squared x minus 1. On the other hand, what if we took the cosine squared of x, and using the Pythagorean identity, we switch that to be 1 minus sine squared, then we have 1 minus sine squared minus sine squared, and that would give us 1 minus 2 sine squared. So there's 3 different formulas for the double angle for cosine. And it turns out that depending on what our integral is, we're going to want to use the second one or the third one. So now let's look at an example. What if I want you to find the integral of sine squared of x? Without me prefacing this with the double angle formulas, you might look at that and think, oh, well that's like an exponent thing, so it's probably 1/3 sine cubed of x plus c. But then if you differentiate this to check, the derivative of 1/3 sine cubed, well, first of all, something cubed, so we would multiply the 3 times the 1/3, which would cancel and give you 1, and then that would bump down to be sine squared. But then there's the chain rule, then we have to take the derivative of sine, which is cosine, and then the derivative of a constant is 0. But that's sine squared cosine, that's not just sine squared. So that doesn't work, so that isn't the antiderivative. And you can mess around for a while, but the only way you're going to wind up solving it is by using this double angle formula. So let me write this over on the side. We have cosine squared, we have cosine of 2x is equal to 1 minus 2 sine squared. Let's rearrange this equation and solve for sine squared. If I move the 2 sine squared over to the left side, and then I subtract the cosine of 2x over to the right side, we're going to have 1 minus cosine of 2x, and then we'll divide that 2 that was with the sine, and so now we have sine squared by itself. So now what I want to do is I want to replace sine squared in my integral with the right side of this equation. So finding the integral of sine squared is equivalent to finding the integral of 1 minus cosine of 2x all over 2. Well, I don't want to deal with the fraction dx, and I don't want to deal with the fraction, so I'll pull the 1/2 out. So we're doing 1/2 the integral of 1 minus cosine of 2x dx. Okay, so antiderivative of 1 is 1x. What's the antiderivative of cosine of 2x? Well, it's going to be minus the sine of 2x, except when you take the derivative of sine of 2x, with the chain rule you also have to take the derivative of 2x, and that would give us a 2, so I need to offset that with a 1/2, and then plus any constant. So, differentiate that just to make sure you get 1 minus cosine of 2x, and you'll see that you will. And now I'll distribute this 1/2, so our final answer I have 1/2 x, or x over 2, minus 1/4 sine of 2x, and then 1/2 times a constant. You don't write 1/2 c, I mean I guess you could, But since c is just a constant, multiplying it by a half just gives you a different constant. So I'll just make it look a little different. And there you go. So that's how you deal with integrals with a sine squared or with a cosine squared. In the next lesson, I'll show you some variations when we have more complicated versions with sine or cosine to a power. Alright, so those were two special examples. So now I want to focus on a certain type of integration, and that's when we're dealing with an integral of f of ax plus b dx. So for example, let's look at this, the integral of 3x minus 2 quantity to the fourth power. So your first instinct should be, alright, it's to the fourth power, so if it was just x to the fourth power, the antiderivative would be 1/5 x to the fifth power. So let's start there. So 1/5 times 3x minus 2 to the fifth power. Now let's differentiate and see how close we are. When you take the derivative of this, 5 times 1/5, that cancels. And then you have 3x minus 2 to the fourth power. But then the chain rule times the derivative of the inside, which is a 3. And we need to offset that 3 because we don't have a 3 in our integrand. So I'm going to need to multiply my answer by 1/3 to account for that chain rule. And then as always, don't forget plus any constant. So final answer here is going to be 1/15 3x minus 2 to the fifth power plus c. Okay? At any point as I work through these, it's really important when you think you have your antiderivative, differentiate it and check. Let's look at another example. How about the integral of 4 over the square root of 1 minus 2x? Now hopefully you've done enough integrals at this point where you realize that maybe we should rewrite this as the integral of 4 times 1 minus 2x to the negative 1/2 power. Okay, so antiderivative. So first of all, the 4 is just a constant. That'll be out in front. Now, we want to add 1 to the exponent. So negative 1/2 plus 1 is going to give me a positive 1/2. And I need to offset that by the reciprocal, so a positive 2 over 1. And then I have 1 minus 2x to the positive 1/2 power plus a constant. Okay, so let's see how close we are. If I differentiated this, I would take this 1/2, multiply it out in front, which would cancel the 2, and then I would lower this by 1, which would make it negative 1/2. Seems pretty good. Except, then I would also have to multiply my answer by the derivative of the inside because of the chain rule, and the derivative of the inside is a negative 2. So that means that I'm going to need to offset that negative 2 from the chain rule by multiplying by a negative 1/2 as well. Alright, so final answer, we're going to have a negative 4 times 1 minus 2x to the 1/2 power plus c. Or if you wanted to write that as a square root, that would be fine. Just to make sure you see where we're at here, let's take the derivative of this thing to make sure. I have 1/2 I multiply out in front times the negative 4, and I get 1 minus 2x, subtract 1 from the exponent, it becomes negative 1/2, and then the chain rule times the derivative of the inside, which is negative 2, and then the derivative of the constant is 0. So these negatives cancel, these 2's cancel, and I'm left with 4 times 1 minus 2x to the negative 1/2, which was my integrand. So I know it checks, and I have the right answer. So as I've said several times before, integration is an art form. It's not like you can follow certain steps and come up with your answer, like it was finding derivatives. But the nice thing about integration is with enough practice, you start to learn some of these techniques, which makes it easier and easier, but you can always differentiate your final answer to make sure that you have the correct solution. Alright, let's look at another one. How about the integral of 2e to the negative 3x? So let's start with basics. We know the derivative of e to something is e to something. So we start there, plus a constant. Now if I differentiate this, I'm going to get 2e to the negative 3x, but then with the chain rule, I have to multiply times the derivative of negative 3x, which is negative 3. So I need to offset that with a negative 1/3 out in front. So now my final answer is going to be negative 2/3 e to the negative 3x plus c. Once again, differentiate that just to verify that we do get what we started with. Alright, let's try one last example. How about the integral of 1 over 4x minus 1? Now, remember back when we did the integral of 1 over x? So hopefully that's what you recognize for this one. And so it's going to be the natural log of the absolute value, hence the opener, of 4x minus 1 plus a constant. If I differentiate this, the derivative of natural log of something is 1 over something, but then with the chain rule times the derivative of the inside, what's the derivative of 4x minus 1? Just 4. So I need to offset that by multiplying by 1/4. And there's your final answer. Alright, so as I keep saying, practice makes perfect. You really have to practice. There's a lot of parts to some of these problems in 18F, so I've just kind of tried to pick and choose so you didn't have to do all of them and it got repetitive. So I tried to pick some different kinds of examples. That's why it looks like a crazy assignment. If you have any questions, please shoot me an email. I'll be happy to help you out.